Well, this part of the video is starting out on the right foot. um, it really helps when you turn your microphone on before you start talking. So I'm going to shoot this one all over again. So as you can see, I have the top side of the chassis mostly mounted up, all the parts and everything. There's a few things I left out on purpose, and we'll get to those later on. And then what I did was I removed these 5 legs and transferred them over to the front of the top side of the chassis. So now I can lay it face down and it'll sit up on these, and that'll make it a lot easier to work on the amp while I'm wiring it. So let me get this thing flipped over now that you see it. That gives you a rough idea of what it's going to look like. Now I didn't put the covers on the transformers because I don't want them to get scratched up. They will scratch very easily. They'll probably end up getting some scuffs on them anyway. It's just inevitable, but I'm going to try my best not to. So let's get this flipped over and get to work. Okay, looking at the underbelly, this is what we have. And what I'm going to do is I'm going to put a little bit of protective sleeving over all the wires where they come through, if they don't already have them. This is where the power supply is going to reside, and you can see our actual amplifiers up here with our test points, and here's our negative 4 ohm and 8 ohm terminals for each side. Here's our power connector where our mains is going to come in, and everything looks like it's laid out pretty well. It's kind of what I envisioned, which is pretty amazing for me. So what I'm going to do now is I'm going to get to work on this amplifier module, like I said. And this video is going to, by and large, be a solder and chat. And while I put this together, we'll kind of talk about where we're going to go with this whole thing and whatever else ends up coming up. You know how those end up. The conversation can go anywhere. Let's get started. Okay, what is worse than not having the parts you need to complete the project that you're working on? Anybody? Not having one of the parts you need. Yeah, I need a couple of resistors that I don't have anywhere in any of my stash anywhere, so I'm going to have to make a special order just for a couple of stupid resistors. But that's how it goes. So anyway, let's get on with it. I'm going to use this bracket, this Panavice PC board bracket, to hold this at a little bit of an angle, kind of make it a little easier to work on, but most of all because if I try to put this flat on the table here, the glare from all the lights is just terrible, and no matter what lights I use, I get glare. It's just the way this board is, so hopefully this will make it a little easier. Now, a few of the components I have, I might have the right value of resistor, but not the right wattage. Just a bunch of little things like that. So yeah, this is going to be fun. Let's start with this 150 volt Zener diode, or Zener diode, whatever you're comfortable with. And that's going to be this one up here. And this is for our negative 150 volt bias supply. I'm going to put this in. Like I said, I'll let the camera roll a little bit here, and then I'll decide what parts to cut in and out later when I edit the video. But it's kind of hard to get that, strike that balance of the amount of solder and chat you like, or when it gets monotonous, you know. But I'm just going to do what I do, and through the wonders of technology, you can use the fast forward slide or button or whatever on YouTube when you're viewing it, and that's no problem. So put that on there, and you can technically, since these are plated through holes, you can solder them from the front if you want. I do that sometimes. That way I don't have to flip the board so much. But it's still nice to flip the board because you got to cut the leads and all that sort of thing. Okay, 470K. Some of these are higher wattage than they need to be, but I have them. Using a higher wattage resistor sometimes is necessary with tube gear, because remember, you've got hundreds of volts, and it doesn't matter that they're not going to dissipate that many watts. What's really important is they are going to have a lot of voltage across them, and some of the lower wattage resistors aren't rated for more than 300 or 350 volts. So if you're going to put 400, 500 volts on them, that's not going to work. So it's just one of those things. Figured I'd go old school with the Panavice instead of some of the newer board holders I was using. Should probably put the vent on, the air cleaner, but it's so loud. I kind of like the quiet down here right now. And the smoke is just going straight up. It's not really anywhere near me, so I don't really care. That makes it too hard to talk, and just listening to that loud fan and everything is annoying. So we'll do it without it. You know, I didn't have all the air cleaners and stuff when I was younger. As a matter of fact, when I started out as a kid, I really started being interested in electronics, believe it or not, at age 9. When I was 9 years old. I think it's because I had 2 cousins that were a good bit older than me, and they were both really heavily into electronics, and I saw what they did, and it just fascinated me. I don't know, it's just one of those things. But of course, when you're 9 years old, you don't have anything, and your parents don't really know that you're going to be interested in something to make that kind of an investment in it yet, even if they had the money to do so. So you really don't have a lot to work with when you're a kid, or when you don't have a lot of money, which I was both. So I started out with a Radio Shack 1 kilo ohm per volt multimeter. It didn't even have a switch on it for ranges or anything. It just had like different jacks that you plug the probes in for what range. And I think it only had one range for ohms, and that was kilo ohms, you know, times 1K. And that was my first meter, and I worked on a lot of stuff with it. And the little tiny meter is about that big. It was the cheapest one you could buy from the Radio Shack catalog. I'm sure all of you are familiar with it and have seen them before. But I used that thing for a long time. My first project, I actually wanted to do a video on it. And I wanted to and I might still do one. But my first project was a 12-volt power supply, so we could use our CB radio in the house. Because my dad had a CB, and we wanted to be able to hook it up in the house and listen to it. And I asked my cousin, and he drew what would be the first schematic that I would ever see. And all it was a transformer, a bridge rectifier, and a capacitor. And that's where it all started. I was hooked. But that story is too good to just tell on a solder and chat. I might make that its own little video, because really there is a moral to the story, and that is that sometimes when you pay attention to a young person, and when they're interested in something, you take the time to talk to them and help them to understand, even though they're young. You never know, you might change that child's life, and you may help them find what their calling in life is going to be. You know, for me it was the electronics thing, but honestly, that's a good lesson to learn. That's why when young people ask questions and things, I always stop what I'm doing and I will take the time to talk to them and answer their questions. I really hope that all the parts marking on here are correct. If you notice, you may have noticed here, I had a couple of mistakes in here. So I had to put this extra diode in here for the chokes. You can see there, and I had sent the board out before I added that. So I had to do this little modification here. And then there was another one where I showed two 470 microfarad caps. Those are very hard to find. So what I ended up doing was I paralleled some 220 microfarads to one another. So really there's a 220, 220, 220, 220, and when they all add up, it's going to be a 470 or 440 microfarad capacitor at really high volts. But the thing is, the way I wired these bleeder resistors, it's not correct. That would be right here. That I needed to fix that. That resistor has to go, this trace, instead of going to ground, this trace should have gone over to this other resistor. Because you see how you have these two resistors in series and they tap at the center of where these join together. And that was not doing that. So I have to put a lead from here to here and a lead from here to here. So I cut that. And of course, the chuck of my Dremel tool hit this up here, and that's what caused those little scuff marks there, which ticked me off a little bit, but hey. So anyway, that's what that is. But I had to do those couple little bodge jobs, whatever you want to call them. And a couple of these resistors I don't have in stock. Some of them I do. What's this one? 220K. I have those. Let's see. And I am elevating these off the board a little bit, although I don't think it's necessary, because these are, the resistance of these, or I mean the wattage of these is much higher than the actual wattage of the circuit. They're going to run really cool. But anytime you're dealing with these tube amplifiers, you know, with high voltages and things, it's always good to get these up off the board a little bit. You never know if they're going to run a little bit warm. Again, I've never built this circuit, so this is the first time I'm going to see it in action. So I'm, out of an abundance of caution, I'm running these at higher, you know, the components at a little bit higher ratings than they need to be. Let's see, is that going to be long enough? Probably not. That should make it. And then this one has to go down there. I'll deal with that later. Let's see if I can straighten this out and get enough. I really don't like them not being long enough like that. I'm going to actually just put a actual piece of bus wire on there. I think that'd be much better. I have a whole spool of it here. So let's do that. And these are just little bleeder resistors, so I don't even know if I need it to be that heavy of a gauge. See if I have something a little bit thinner in here. I can reach around here. Yeah, this is better. Okay. So I'll just put this in here with this. Oh, over here, I mean. There we go. Tack that in. I'm sure all the purists are having a conniption right now. Oh well. I'm not a purist. I'm not afraid to do some things like this once in a while. You know why? Because it's not an X-ray machine and there isn't a whole bunch of crazy laws on it, and I don't have to worry about it. I spend way too much time with that. kind of like this. It's a piece of audio gear. Nobody dies if it's not right. Although some folks out there might feel like they're dying if their audio sound stage isn't good enough or whatever that is. But not me. This is fun for me. There we go. How about that? Okay, and then this one goes down to this corner. So I'll snip that. And I don't have the 180Ks. That's one of the ones that I had to order. Like I said, there was a couple resistors I needed to order. I had everything else, but except for those couple of resistors. I'm just making sure these are where they need to be before I tack them down. Okay. All right. These ones I don't have, so we'll have to wait on those. I should probably snip this off too. Maybe I should use these smaller ones. I can get in a little closer. I don't want it too close. You do want a little bit sticking up, but not too much. Okay. Let's see here. What do we want? What do we want to go for next? What do I have? Put this one here. This is for the, again, for the negative bias supply. That's this 1N407 or a UF407. The only difference is one of them is a fast switching transistor or diode, and the other one is just a standard. I'm going to put a standard. I have both types here, but this was handy. It really doesn't matter for this application here. You don't need a fast switch diode. There we go. And I'm taking my time. I mean, you could put a whole bunch of these parts in at once and bend the leads and then flip it one time rather than flipping it back and forth like this. But I'm doing this for enjoyment, so I don't care how efficient I am. That's the beauty of it. There are no patients that are waiting to be treated. It's wonderful. There we go. And no, I don't save my little end cuts. I throw them all away. Like I said before, it's like cutting, it's like saving your toenail clippings. I don't do it. Okay, put these 0.2s in here. These aren't absolutely necessary, but they're just in there. If you had a diode short out or something, and you dump the capacitor bank right across the winding of the transformer, hopefully these, even though these are 5-watt resistors, they will hopefully pop before you blow the winding on the transformer. These probably should be a little bit lower wattage than that, but I don't know. They also will provide a little tiny bit of a soft start if there's a big inrush current, which hopefully we shouldn't see that, but really not strictly necessary. I'm going to put them in. I have some other lower wattage, low ohm resistors, but they're precision flame proof resistors and so forth, and they're kind of designed not to burn up. And these ceramic wire wounds, when you put a huge inrush through them, they can pop pretty easily. especially with real huge current. Now I'm more worried about the a diode shorting, and then that great big capacitor bank dumping all of its current back into the windings. This will hopefully protect them a little bit, if that ever were to happen. Hopefully it won't. Again, this is just all me trying something here. Different things, different ideas. This is definitely a prototype amp, because I've never, I mean, up until I read that book about the valve amplifiers by Morgan Jones, I really never even knew about the Hedge amplifier or any of that stuff. So this is all new to me, which is cool. All right. So let's put this 2.2K up here. And again, like I said, I'll edit this down a little bit as we go. And I'm just kind of eyeballing the size on these, the spacing on the wires. Like, this is a real precision resistor, this 240 ohm. Not necessary, but that's the only kind of 240 ohm I had. All right. Let me get, and this is the power supply for the tail circuit. So that would be the power supply down here. Not this, but the power supply for this down here. So this is providing the negative 12.6 volts. And again, I can change the I can change one of these resistors, and it'll actually make it I can change the output voltage if I want to raise it a little bit or something. All right, while we're at it here, we might as well just do this whole thing here, this whole side. Let's see. For the bridge rectifier, it appears that this is ground, and this one up here must be the positive. Yes, it is. So I want to make sure I get that in there the right way, because desoldering this is going to suck if I get it in here the wrong way. So this is negative, and this is positive. All right. Isn't that a cute little bridge rectifier? All right. Yes. I think we got it right. Even if I make it idiot-proof, I'll just turn into a better idiot. That's what happens. But hey. So anyhow, yeah, when I was really young, I started in electronics, and I really didn't have anything. And one thing I did learn about was Heathkit. And of course, I couldn't afford any Heathkits, but my parents splurged on me and ordered me one of those, kind of had the rack or the bracket mount real wide. It was a VTVM kit. It was a kit. I forget the model number, but it was one of those one. It wasn't the real common one, you know, the one that was tall. It was the real wide one. And the probe, you built the probe too, and instead of having one of those microphone jacks or a BNC jack, it had a 1/4 inch phone jack. And that was my first really good multimeter. It was a VTVM, and I built that kit, and I used that thing like crazy. And I'll be honest when I moved and everything and I left home, grew up, all that good stuff, I have no idea what happened to that meter. I know that I put it somewhere that I would never lose it, but when my mother sold the house after my dad passed away, the house sold 2 days after it went on the market, and we didn't expect that. And I was very busy at the time, and a lot of my stuff ended up going in the dumpster or given away or whatever, because I just didn't have any place to put it. I didn't have any time to go through it. Lost a lot of, I had, Tannoy 15-inch dual concentric speaker that's worth a ton of money now. It got thrown out. Had a big Tesla coil that I built out of X-ray machine parts and things with a control module rolled around on wheels and everything. That got thrown away. I had ICO vacuum tube amplifiers, with the 6BQ5s and stuff. They disappeared. Lots and lots of equipment. Had quite a good amount of automotive things, like engine stands, engine hoists, different things like that. They all went the way of the dodo bird. And, you just have to let things go sometimes. But, by then I was married and had kids and, just didn't have time to get into this. And I'm kind of just glad I could get back into it again, really. This has been a lot of fun, and then the whole YouTube thing just happened, and I'm very happy with that too. I've made a lot of friends and a lot of acquaintances through YouTube. Probably a lot of you who are watching, and it's really been fun. It's been a good journey. I like the fact that some of these modern technology things have turned out to have, good things associated with them. Quite often you see media and things like that used to spread propaganda or hatred or, false information. But it's so nice also to be able to meet people and talk to one another and learn from one another. That's the good side of it. And I think the only difference between the two is our attitude and our choices that we make. We can complain about this, that, or the other thing, but really the buck stops at us. I guess that's why that song by Styx, The Grand Illusion, is one of my favorite songs. The lyrics to that really kind of register with me, especially the very last, the last phrase in the song where he says, "And someday soon we'll stop to ponder what on earth's this spell we're under. We made the grade, yet still we wonder who the hell we are." Isn't that the truth? So, all right, there's our little negative 12.6 volt supply. Have an LM337. It's not on the schematic, but it is on the board. But all it consists of is the bridge rectifier, filter capacitor, the LM337, and then the two resistors that set the actual voltage, which we can change that if we want to modify the voltage. And this will connect to that extra winding that we did on the transformer on that previous video that I did. So that's all done. Okay, this is an interesting component, and where it is on the schematic is this one right here. And it's a 4.7 microfarad 630 volt capacitor. Now, you could certainly put just an electrolytic on there if you could get a big enough one. But I have a lot of these things from my job. These old boards, with inverters and things. And you can see I have a lot of these big film capacitors. So I had this. It's 4.7 at 600, 1200 volts DC. And so I made the board for that, but that's a big enough area that you could pretty much put any capacitor you want in there. But I think if you wanted to buy one of these, I don't think they're real cheap compared to an electrolytic. But there again, I don't know where you're getting electrolytics of that size are going to be kind of hard to find. You have to remember, you know, this thing is going to be 560, 570 volts, something like that. It could even be a little higher depending on your mains voltage when the thing first powers up. And so you're putting a lot of stress on that capacitor, especially being half wave rectified. It's going to have a lot of ripple on it. So I think this is actually going to be a good choice for this. Do you need this? Probably not. If you got a really good quality electrolytic, it's going to be smaller than this for sure. Even at the higher voltage, it's only 4.7 microfarads. But if you got one with low ESR that can handle high ripple current, then, you know, I think it would be okay. But I had it. I'm using it. Again, not something, if we were going to do this commercially, not something that I would probably want to have on a finished product. You know what I mean? Like something that I would sell or, you know, share. I'll still put the Gerbers up. You know, any of my patrons that want this, I'll make the Gerbers available if you want to order these boards. I had JLC PCB do this. Their pricing was a little bit better than PCBWay, and I've been using them a long time, so I'm real familiar with them. Although I've heard that PCBWay is really good with doing you know, discounts or whatever if you feature their circuit boards on your videos in your channel. But I've never really done that. I just don't want to do that. I don't want to get into all that. It's just extra work for me, and I don't want to feel like I have to plug somebody, you know, put in a plug for somebody just because they gave me a circuit board or something. I'd rather just pay for it fair and square. It is what it is. JLC did a great job. I mean, you know, and I'm saying that just because I'm happy with what I got from them, from what I purchased. Okay, 100 ohm. I don't have a big 100 ohm resistor, so that one's going to have to wait. Okay, these two big capacitors here are these 100 at 525. The ones I actually have are 100 at 550. They're snap-in type. And those go right here, right after the choke. And then that's going to feed this, which is the one that's going to be off board. I showed you this, the heat sink and the two transistors that we're going to use for those. Those are not going to be on the board. They're going to be on a heat sink that's kind of elevated on an insulator. And then this, I just had to snip off one of the leads. This one had two prongs on this side and one on this side. And I spaced out the board, so these will just snap in like that after cutting that off. Just like so. So these are the two separate power supply caps for the two 300 volt supplies for one, you know, one for each channel. Hopefully they'll stay put till I can solder them in. Oh yeah, they're in there. They did their job. They snapped in. The only problem with these plated through holes is once you solder that part in the first time, good luck getting it back out. Even with a desoldering station, not easy. Okay, I have this 22 at 250 for right up here, and that's going to be this. And that feeds the negative 150 volt bias supply. So that'll pop in right like that. Okay, for all of these capacitors, that's going to be the 220 microfarad at 400 volts. 1, 2, 3, 4, and then 5, 6. Don't forget about those. These are what I'm using. And these are really good Nippon Chemicons. 105. So they'll last a long time. And this one here, I put some extra heat shrink on the base because look how close we are with our diode. And I also put some silicone around there. I'm being, you know, a abundance of caution. That being said, this is not connected to these leads. The can is not connected to the negative on these. It's isolated, but you never know. So I just, again, out of an abundance of caution. So I'll get these all installed and these all installed. I'll be right back. Now you can see I printed out the layout of the board here from KiCad. And you can see the couple of places that I'm making a couple changes in here. So I will have to definitely do that. So we're going to do that right now. And this capacitor here, I don't know that I'm going to need that anymore. So that's going to stay out. And I'll have to do a couple bodges on the bottom of the board. And there we are so far. So I need to put another little turret over here, and that's where the 96 volts will be connected. Actually, I could probably just use this little solder pad here. I won't need that. Everything else should be good. And I just have a couple little film caps to put across here. I'll do that later. I don't have the correct 430K resistor, so that was one of the ones I had to order. And this big 47 ohm I'm probably going to put off board, although I don't know that it'll get that hot. I'm still going to mount it underneath this just to get it off the board. Anything big like that, I don't really want to be there. And this is overkill. It doesn't need to be this many watts, but again, I just want everything to run as cool as possible, so I'm oversizing them. And then I need this 100 ohm, and I need this 150K, and these two 180Ks. And that should do it. Okay, so I took a break for the night, and when I came upstairs, and I just, in the back of my mind, I realized that I had put these two components in backwards. This one is marked incorrectly on the board. This one was marked correctly, but I looked at you know, at that one, the one that was connected to ground, and I'm like, wait a minute, this is backwards. Well, this is a negative power supply, so the positive does go to the ground. So yeah, so I had to take this out this morning and take this out and flip them around. Now we're good. I also replaced that 2.2K with a 2.7K. That's going to give us 15 volts output instead of 12. Negative 12, negative 15 instead of negative 12. And in the process, of course, I touched this little film cap on the corner with my soldering iron, which I hate seeing that. It's one of my pet peeves, is seeing a burn mark on a complete. This doesn't hurt anything, and I'm going to leave it in here, but don't you hate when you do stuff like that? It kind of leaves a sign that you were there, you know. But anyhow, my soapbox about that. So anyway, I'm waiting for these last couple pieces to come in. And once they do, I'll get them installed. And then we can start wiring this up and see if we can get some basic power to the power supply. We'll put a dummy load on it of some sort, and which should be a little bit fun. But I think I have some big resistors we can use. And make sure everything works as advertised. If you don't have a good power supply, there's no use in starting to build out the rest of the system. So I want this to be perfect before we move on to the next step. So that's what we're going to do. So next time you see me, we'll have some resistors in. Hopefully that'll be tomorrow, and we'll get it wired up and we'll start testing. Okay, so our last few resistors came in and I got them installed, and the couple little bodge jobs I had to do, I got those in. So now we have all the connections we need, and it's now time to get this mounted up on the chassis and get it wired up to the power supply transformer. Okay, we have a whole lot of wires, and we need to get them all connected and then get this mounted here. And what I'm going to do is, you can see this 47 ohm resistor, I mounted it to the chassis, and that'll get wired in, here and here. The two pots for the bias and balance, I'm going to put here in between the test points, so they'll be out of the way. I'll mount those. And then once I get these wires connected in here, before I go do any of the circuit wiring, we're going to test the power supply thoroughly and make sure it works under load, and make sure it produces the proper voltages, make sure I didn't make any mistakes. And we'll bring it up slowly on a variac and a dim bulb tester, and I will share that all with you when I do it. But that's going to be for the next part, because I'm going to end this one right here. And as always, I'm going to wish you all peace, joy, happiness, and good health in your lives. And we'll see you again here real soon. Take care, everybody. Bye-bye.